Hi, I'm Tina from Prep 101. In this video, I'm going to review the CAST rule with you. This is important throughout the course for solving derivatives and antiderivatives. Okay, let's get started. So the CAST rule, if you draw your four quadrants, we label a C down here in the bottom, and then we spell out CAST going up and around. So this is the CAST rule, and what it means is if we look at the C quadrant, C stands for cos, so that means cos is positive. And that means that the other two ratios, sine and tan, are both negative. Now you can also talk about the reciprocal ratios. So if cos is positive, then 1 over cos, which is secant, is also positive. And we can talk about the reciprocals here. Cosecant would be negative and cotan would be negative. In the A quadrant, A stands for all, so all ratios are positive. So sine, cos, tan, sec, cosec, cotan would all be positive in the A quadrant. If we draw an angle over here in the S quadrant, S stands for sine, so sine is positive. And of course, that would mean cosecant would be positive. The other ratios, cos would be negative and tan would be negative. And of course, 1 over cos or sec would be negative, and 1 over tan or cotan would be negative. And down in our T quadrant, we know that T stands for tan being positive. So tan is positive, cotan is positive as well. And sine and cos would both be negative in the T quadrant. And so, of course, cosecant would be negative and secant would be negative. So that's what the CAST rule tells us. So now let's do a whole bunch of examples. And this is going to be useful on the exam when you get to midterm and final questions, when you're talking about doing a derivative and evaluating it at a certain angle, or doing an antiderivative and evaluating at the end at a certain angle. So you need to be able to finish the question, so that involves the CAST rule quite often. So first example here, we've got cos of negative 4 pi over 3. So we have to think about, where does negative 4 pi over 3 go? So these are both, A and B both involve the same angle, so I'm just going to draw it once. And negative means that it moves in the opposite direction. So instead of moving this way, from here across up to the top there in a counterclockwise position, or in a counterclockwise direction, we're going to move down this way. So a negative angle would go towards the bottom here like that. So that's where we draw a negative angle. Positive angles, we start at positive x and go up and around towards the top here. So negative 4 pi over 3. Well, negative 3 pi over 3 would be pi. So a negative pi would go all the way to here. That would be negative pi. And we have to go a little bit further. So we're actually up in this quadrant up in here, which if we draw our CAST rule is our S quadrant. And so we know that this whole angle here, the whole thing is negative 4 pi over 3. The negative we don't need to worry about anymore. That was just the direction we were going in. So if we think of this as negative pi, how much more do we need to get to negative 4 pi over 3? Or if we think of this as pi, how much more do we get to 4 pi over 3? And just forget about the negative altogether. Well, this would be a pi over 3, right? A whole pi plus a third of a pi would be 4/3 pi over 3. So this is our pi over 3 triangle. That's our angle. And we're looking in the S quadrant. So if we want cos of negative 4 pi over 3, the only thing we have to do is the cos of pi over 3. And then remember that we're in the S quadrant. So that means if we're in the S quadrant, then cos of negative 4 pi over 3 is negative cos pi over 3. The negative is because we're in the S quadrant, and cos is going to be negative in the S quadrant. And cos pi over 3, then we're just going to look at our special triangle, draw it out. 3, 2, 1, pi over 3 is the bottom. And cosine, well, we know we need adjacent over hypotenuse from SOHCAHTOA, adjacent over hypotenuse. Adjacent is touching pi over 3, that would be 1. And hypotenuse is always across from the right angle, so that would be 2. And so our answer would be negative 1/2 for part A. For part B, we've got sine of negative 4 pi over 3. So it's the same angle, but if we want the sine of that angle, we're in the sine quadrant. So this will be positive sine of pi over 3. So the same as sine pi over 3. And if we look at our triangle here, sine would be SOHCAHTOA, opposite over hypotenuse. And so opposite from pi over 3 is go across the triangle. So we would get root 3, and hypotenuse is the 2. So this would be root 3 over 2. And that would be our answer. Okay, now let's look at positive 4 pi over 3 as an angle. So we want sine of 4 pi over 3. So we need to draw out, what does that look like? Well, it's a positive angle, so now we're going in the usual direction that we're used to, up towards the top. And if we did pi, we would go all the way around to here. That would be pi. So we need to go a little bit further, another third of a pi. So that's pi to there. So if we want to go all the way to here and make it 4 pi over 3, then that means, again, this has a pi over 3 inside our triangle. The pi takes us to here, and the pi over 3 takes us to the, what we call this whole terminal arm here. And so, well, we want sine. So which quadrant are we in? CAST. We're down in the T quadrant. So the sine of 4 pi over 3, it's not going to be positive because we're doing sine in the tan quadrant. So it's going to be negative sine pi over 3. And then again, you can practice drawing your triangle here. Root 3, 2, 1. Pi over 3 is the bottom angle. So from SOHCAHTOA, we get opposite over hypotenuse. We know it's negative because we're in the T quadrant and we're dealing with sine. So opposite is go across, root 3. Hypotenuse is across from the right angle. So it's negative root 3 over 2. And that would be our answer here. And part D says tan 5 pi over 6. So we need to figure out where would we draw the angle 5 pi over 6. So that means 5/6 of the way to pi, so almost a whole pi. So if we draw our quadrants here, all of pi is the whole top, so we're going around to here, and we're saying that that's 5 over 6 of pi, or 5 pi over 6, same thing. So how much do we have left to be inside the triangle? Well, if we have 5/6 of pi plus 1/6 of pi would be a whole pi. So 5 out of 6 plus 1 out of 6 pi. So in other words, the angle in our triangle is pi over 6. Now look at your CAST rule, C-A-S-T. So we want tan 5 pi over 6, but we're in the S quadrant, the sine quadrant. So that means that tan 5 pi over 6 is negative tan of pi over 6. And again, you can practice drawing your triangle as many times as you need to until you've got it memorized. Root 3, 2, 1. Pi over 3 is the bottom angle. And this time we want to look from pi over 6. So if we look from this angle, tan is SOHCAHTOA, opposite over adjacent. And it's negative because we're in the sine quadrant. So opposite is go across. So we get 1 over adjacent is touching the pi over 6. So that would be root 3. So we get negative 1 over root 3. Okay, and we'll do a couple more here just for extra practice. So 2 pi over 3, and we're dealing with cos this time. So draw your quadrant and see if you hit pause, if you can figure out where would you draw 2 pi over 3 as an angle. Okay, so 2 pi over 3 is 2/3 of the way to pi. So pi is from the positive x all the way around to here. So we're going 2/3 of the way to pi. So that's 2/3 of pi, or 2 pi over 3. Okay, so that's our angle. So what's our angle left inside the triangle then? Well, 2/3 of pi plus how much of pi would be a whole pi? Think of it that way. 2/3 plus pi over 3 plus 1/3 would be a whole pi. So we're looking at our CAST rule. We're in the sine quadrant, and we've got an angle that we're dealing with of pi over 3. So cos 2 pi over 3, if we're in the sine quadrant, is going to be negative of cos pi over 3. So in the sine quadrant, cos is negative. And then we look at our triangle, and what is the cos of pi over 3? Pi over 3 is the angle at the bottom. Remember cos, SOHCAHTOA, so adjacent over hypotenuse. And from the pi over 3, adjacent is touching it, so the 1, and hypotenuse is always across from the right angle. So our answer would be negative 1/2. Now, part F is asking for cosecant 7 pi over 6. Cosecant 7 pi over 6. So 7 over 6 of pi. So that's a little bit bigger than 6 over 6. 6 over 6 would be 1 whole. So we know when we go to draw this, we want to be a little bigger than pi. So pi would be all the way to here. So it's a little bigger than that. So that's 7/6 of pi, or 7 pi over 6. So that means that this whole from here to here is 6 pi over 6. That's 1 whole pi, 6 pi over 6. So plus 1/6 would be 7 pi over 6. So we're looking at the angle of pi over 6. And what quadrant are we in here? We're in the T quadrant. So first thing I ask myself is, which one is cosecant, right? What is it the reciprocal of? Cosecant is 1 over sine. So first thing I'm going to do is deal with sine 7 pi over 6. So sine of 7 pi over 6, we're in the T quadrant. So it'd be negative sine of pi over 6. Negative sine pi over 6. So draw your triangle. Pi over 6 is your top angle. And we're looking at sine, so SOHCAHTOA, opposite over hypotenuse. So opposite from pi over 6 would be 1, go across the triangle, and hypotenuse is the 2. So the answer for sine 7 pi over 6 would be negative 1 over 2. So if we want cosecant 7 pi over 6, we know we have to flip or do 1 over the sine of 7 pi over 6. So we do 1 over negative 1/2, which would be negative 2. And so that would be our final answer for cosecant 7 pi over 6. Okay, in G, we're doing cos of 11 pi over 6. So again, I'd like you to pause the video and try the next two and see how far you can get on your own. So 11 pi over 6, 11 pi over 6 is, we're looking at almost 12 pi over 6. 12 pi over 6 would be a whole revolution, 2 pi, all the way around. So we're almost all the way around. So we're going all the way into this quadrant here. So there's our right angle there. So this is 11 pi over 6. And so 11 pi over 6 plus 1 pi over 6, or just pi over 6, would be 12 pi over 6. So the angle that we want in our triangle is pi over 6. And we are in the C quadrant. So this time, if we want cos and we're in the C quadrant, then it will be positive. So cos 11 pi over 6 is positive cos pi over 6, because we are in the C quadrant. And again, we can draw our special triangle. Root 3, 2, 1. You've got pi over 6 here. And SOHCAHTOA, we're looking at adjacent over hypotenuse. So adjacent is root 3 and hypotenuse is 2. So this is positive root 3 over 2. And the last one here is asking for cotan 5 pi over 6. So cotan is 1 over which ratio here? Cotan is 1 over tan. So the first thing I'm going to look at is looking at tan of 5 pi over 6. So we'll say, what is this first? Okay, so let's draw. Where would 5 pi over 6 be drawn? 5/6 of pi. So that's almost a whole pi. So that would be up here. 5/6 of pi, or 5 pi over 6. So if we look at that as an angle, if from here to here is 5/6 of pi, then we add 1/6 of pi, or pi over 6, and that will get us the whole top. So the angle we want is pi over 6, and we are in the S quadrant. So if we want tan 5 pi over 6, and we're in the S quadrant, it would be negative tan of pi over 6. And tan, SOHCAHTOA, would be opposite over adjacent. So let's draw our triangle again. Hopefully you've got it memorized now. So we've got root 3, 2, 1. Pi over 6 goes at the top of our triangle. Okay, so we want opposite over adjacent. So from pi over 6, opposite is across, adjacent is touching, so we get -1 over root 3. And finally, we didn't want tan, we wanted cotan of 5 pi over 6, so we flip the -1 over root 3. So it'd be root 3 over 1 with a negative in front of it, or just negative root 3 in the end. I hope you found this video helpful. If so, see more videos in this playlist. Don't forget to join the Facebook Study Hub. Use the link in the video description box. Also, I hope to see you at my prep sessions, where I'll show you lots of tricks on how to ace your exam. I'll go through every problem that you need to solve, and you'll solve them with confidence by the end of my prep sessions. Many of our prep sessions are free, so go to prep101.com now for more details and to sign up. I hope to see you soon. Take care. Bye.